Happy Earth Day, everybody. My name is Ben Maurer, and I'm at the National Renewable Energy Lab. I'm one of the staff members that helps put on the Power at Sea Prize, and wanted to welcome you all to our Explore webinar. We are going to go ahead and get started. There's a few housekeeping items at the beginning here. You all should know that this webinar is being recorded. That webinar recording and question answers will be available on the HeroX platform, ideally by the end of the week, but possibly early next week. So go ahead and head over to HeroX next week and look for them there. For the webinar itself today, while we're presenting, we ask that you post your questions in the Q&A in written form, and we will answer them at the end of the presentation. It just helps us keep track of things and then also provide a written record later of the questions that were asked. So please do post your questions in the Q&A. With that, I will hand it over to Linnea, who's going to run us through the agenda.
Hi, everybody. I'm Linnea. I'm with Pacific Northwest National Laboratory, also supporting the Power at Sea Prize. And today we're going to be talking to you a little bit about the different types of marine renewable energy that are out there, some example applications, the challenge areas that we're hoping you will be able to help us address through this prize, and then a general overview of the prize itself. So marine renewable energy is power produced from the ocean from a variety of different sources. This can be waves, tides, ocean currents, salinity gradients, and thermal gradients. This is most commonly done with tidal turbines and wave energy converters. But even within those categories, there's not a one-size-fits-all device that works for everything. We're hoping that you'll be able to help us find new ways of doing this, but we're going to give you this overview to show you what's currently out there. But I do want to say, just because something is not mentioned in this presentation does not mean that it's not fair game for the prize. So tidal energy is power produced from ocean tides. Traditionally, water drives a turbine to produce electricity. There's a couple of ways that this can be done, some of which are horizontal and vertical axis turbines. There's tidal kites, which move through the water column to again drive a turbine. Something called an Archimedes screw, which again drives a turbine. And then vortex-induced vibration devices, which typically take lower speed tides and currents and take vibrations from low speed fluid flow to produce electricity. I've got a general equation for power up here, and you can see a lot of coefficients. Coefficient of performance, CP, is typically specific to a turbine. Rho is density of the working fluid. A is the area of the turbine, and then V is velocity of your working fluid. And you can see that power is much more dependent on velocity, which is cubed, than on any of the other characteristics. So by finding higher speed tidal flows, you'll get much more energy than just by doubling the size of your turbine. Wave energy is power produced from ocean waves. This is typically used to either move a working fluid or drive a generator. Again, I've got that equation for power up at the top, and you can see a bunch of coefficients, and then wave height squared, and wave period. This means that taller, longer waves are going to give you more power than shorter, more frequent waves. Again, there are many different types of ways to gather energy from waves. I've got a couple of images up there of existing devices. On the left, we have the wave roller, which is an oscillating wave surge device. It takes the side-to-side or surge motion of the waves and converts that into electricity. In the center, we have CalWave's X-Wave, and that's a point absorber and takes the up and down heave motion of the waves and turns that into electricity. And then on the right, we have something called an overtopping device, which fills an artificial basin with water from ocean waves. And then that basin is slowly let out through a series of turbines to produce the electricity. So there's a whole bunch of different ways that this can be done. Ocean thermal energy conversion takes advantage of the temperature difference between warm water at the ocean surface and cooler water at depth to generate power. One of the ways in which this is done is that warmer water evaporates a working fluid, which then drives a turbine and is condensed after it leaves the turbine by cool water at depth. This can be done with a working fluid, commonly ammonia, in a closed cycle system, or with seawater in an open cycle system, which can also result in desalination. It can also be done using a hybrid system, which typically evaporates seawater in a vacuum, turning it into steam, which then heats a working fluid to drive a turbine. In addition to producing power in this way, you can use thermal energy to drive buoyancy engines, where changes in temperature associated with your change in depth of the water column change the volume of the system without changing its mass and thus affect buoyancy. We're also going to be going through some of the powering the blue economy markets where marine renewable energy may be able to provide benefit. The Department of Energy produced a report called Powering the Blue Economy, and there's a link to it on this slide, which will be available when all of the slides become available. So you can go through and read a little bit more about each of these in depth, but we are specifically looking for marine renewable energy to power one of these power at sea markets. We are not looking at resilient coastal communities. So this first example is ocean observation. Scientists are interested in characterizing a lot of different things about the ocean, including salinity, temperature, ocean currents, bathymetry, and various activities that go on in the ocean. And there are a lot of different ways to do this. This graphic here, you can find as part of the Powering the Blue Economy Ocean Observing Use Cases report, where we went through and determined how much power some of these will require. You can see on the smaller scale, you can take drifting profiling floats or tsunami detection buoys and power them with tens of milliwatts of power, all the way up to the larger scale where autonomous surface vehicles, autonomous underwater vehicles, radar, and LiDAR require hundreds of watts of power. Each of these are limited by the amount of power that they can carry in batteries. So providing marine renewable energy offers potentially extended mission durations or increased sensors that they would be able to carry. Offshore marine aquaculture is another possible market. This is the cultivation of fish, shellfish, crustaceans, and aquatic plants. I've got a link up here that you can explore later, which goes into a little bit more detail about the particular power requirements of some of these operations. But again, each operation is going to have a different scale of power that they need. The power needs can be affected by the species that's being cultivated, the amount of the fish or shellfish that they're growing, the geographical location, and even the phase of the growing cycle, because fish will need different amounts of food at different places in their life cycles. Again, there's a lot of potential here that needs power that marine renewable energy may be able to provide. These include things like lighting and pumps, and general support barge operations, monitoring of systems, things like that. Specifically, underwater vehicle charging is another market where marine renewable energy may be able to extend mission duration, which is currently limited by battery capacity. Autonomous underwater vehicles are useful for ocean observing, which we just talked about, but also for a wide range of other tasks, things like underwater inspections, and they can be used for military purposes like mine detection and surveillance as well. So we're hoping that marine renewable energy will be able to extend some of these mission life cycles and generally provide a clean, renewable source of power. Marine algae is another potential market, similar to aquaculture, but this is specifically focusing on seaweed and microalgae, which can be grown at sea at commercial scale. These are used in a wide range of different applications, specifically biofuels, food processing, cosmetics and pharmaceuticals. And again, they have very similar power needs to the aquaculture use cases, where navigation lights and maintenance equipment may require power, refrigeration and drying operations. And these farms are currently provided, they've currently received power from things like diesel generators on barges, potentially from batteries, and replacing that with a renewable source of power is desirable. Seawater mining is where you take trace minerals and dissolved gases that can be found distributed evenly, but in small amounts in seawater, and extract those. There's a couple of different ways to do that, one of which is passive absorption, where absorbent films are deployed, which gather these minerals and materials, and those films are retrieved and processed to extract minerals from them. This can also be done with electrochemical processes, where you apply a voltage to seawater, and that input of power separates seawater into its different components, and you can extract minerals that way. These operations need power for the electrochemical process, for deploying and retrieving the absorbent films, for processing, and generally for safety and monitoring equipment. Again, these can be done with diesel generators on barges currently, and with batteries, but applying a renewable energy source will move towards cleaner power, and it may allow more automation as you need fewer trips to refuel diesel generators. And lastly, I want to draw your attention to marine carbon dioxide removal efforts. This is a relatively new field of study, but they're trying to remove carbon dioxide from the oceans in an effort to combat climate change. Methods are varied, and there are a lot of them, but one of them is called electrochemical ocean capture. Here, you take seawater and you separate it into an acidic and a basic component by, again, applying a voltage and using some special membranes, which can separate out the different parts of the liquid. The acidic stream can then be used to specifically take out carbon dioxide and remove carbon dioxide directly from the acidic stream, or the basic stream can be then returned to the ocean, where it can add to the alkalinity of the ocean and allow the ocean to absorb more carbon dioxide from the atmosphere. We can also try to store carbon dioxide in the bottom of the ocean by sinking it to depth, or through micro and macroalgae cultivation, which absorb carbon dioxide as part of their growing cycles. Some of these processes use large amounts of energy, like electrochemical ocean capture. It uses on the order of hundreds of kilowatts. However, all of these need things like sensing and observation, and those are some areas where marine renewable energy may be able to supply enough power. And then I'm going to hand it over to Bree, who is going to talk about some of the challenge areas that we are hoping that this prize will address.
Hi, everyone. I'm Bree Friedman. Now that we've discussed the types of marine renewable energy and their applications, we can dive into some of the challenge areas needed to be addressed to advance power at sea. Good. So the first challenge area is access. This is both access to be able to deploy. Deployments can be really high cost. The equipment can be high cost. And this is also access to the system while deployed. Getting to a system in the ocean can be difficult to be able to do maintenance on the system, check how it's working, anything of that sort. The next challenge is the deployment duration. This can be both limited by the system's life cycle. So like, does it have enough energy to continue powering all of the devices on board? But it can also, deployment duration can also be limited by the durability of the system. The marine environment is incredibly harsh, and so parts break all the time. So that's another challenge. Next slide. The next challenge area is energy storage. This can be both from limits of battery capacity, which goes hand in hand with deployment duration, but it can also, another challenge of energy storage is that batteries can be really large and heavy and take up quite a lot of space on the deployed system. And so reducing the amount of capacity or the size of the energy storage system can be crucial in successful deployments. Another challenge area is environmental and ecological impacts. So anything placed in the water will have some sort of environmental impact. And so this is looking at how can we minimize the negative effects on the aquatic ecosystem as we deploy systems. And that's from looking at fish, from looking at corals, any part of the aquatic ecosystem, and minimizing the effect. Another challenge area is harsh operational conditions. As mentioned when discussing the challenge of deployment duration, the marine environment is incredibly difficult for devices to operate in. And so being able to survive large storms or even just the day-to-day corrosive environment is a huge challenge when looking at deployments of marine energy systems. Marine energy has the potential to integrate with other renewable energy sources to address the intermittency from other renewables. For example, with solar, you only get power when there's sun. So there is a challenge of integrating marine energy with other renewable energy sources so they can work hand in hand to fully provide power for sensors. And then the final challenge area that this prize discusses is the suitability of power. So Linnea mentioned this earlier, but depending on the application, different amounts of power are needed at different times. So maybe you need to power a small sensor every hour, or maybe you need to power a really large system once a month. And so that's going to really affect what kind of power you need to, or energy you need to harvest, and also what kind of capacity of energy storage you need on board. And so those are all the challenge areas that this prize is focused on that arrive with the marine energy. I'm gonna hand it over to Carrie.
Thanks, Bree. Hi, everyone. Carrie Schmass, Technology Manager at the Water Power Office. And I have the pleasure of sharing and reminding some folks what the Power at Sea Prize is all about, and just giving kind of a brief overview before we move into our next session, which will be question and answer. So hopefully folks are familiar, but just a reminder, this is the Power at Sea Prize. There's three main prize goals. The first is to really cultivate a community of both new and existing participants for marine energy. The idea here is to build a group of folks that maybe you're new to marine energy, maybe you're not new to marine energy, but really bringing you all together to ensure that we have sort of the best and brightest minds working on this challenge area. The second goal is, of course, identifying new, innovative, and feasible marine energy concepts. So looking for what those technology ideas are that are out there. And specifically, we're looking for those with a high likelihood of providing power at sea in the near term. So that is our second prize goal. And then the third prize goal is to introduce folks in the prize, both to the Water Power Technologies Office, but also government funding mechanisms writ large, and make sure that you all have the resources and the support that you need to both compete technically and financially for both this prize and future funding opportunities at DOE or even beyond. So we're really hoping to provide a nice kind of background and introduction to government funding mechanisms through this prize as well. Next slide. So we just heard from Bree what those challenge areas are, so I won't go through those again. They are listed there if you want to reference them. But want to talk a little bit more broadly about what this prize scope covers. And so the competitors, you have to propose a tangible system, subsystem, or component. So it could be any of those things. But the key really here is that it needs to receive more than or equal to 50% of energy needs from a marine energy resource. And those are waves, tides, ocean current, salinity gradients, or thermal gradients. So I do want to note that does not include offshore wind. I think that's a pretty common misconception. When we talk about marine energy, we're really talking about waves, tides, currents, and some of those gradients. And some potential example applications. So I want to be clear that these are not all the applications, but just some examples that Linnea did such a nice job going through. But they can include everything from ocean observation, which could include underwater vehicle charging. We would be interested in seeing applications that address power needs of marine aquaculture or marine carbon dioxide removal, or even seawater mining. And so again, that is not a comprehensive list. Those are just some examples of what we think interesting applications at sea could be powered by marine energy, but competitors are welcome to propose other areas and other end uses for our consideration as well. Go to the next slide. So just some very important dates to remind you all of. The concept phase opened back in November. So you'll note we left this open for quite a while. We're really hoping to get a lot of interest and participation in this. And so the date everyone should have on their minds is July 26th at 5 p.m. Eastern time. That is when our concept phase submission closes. Shortly after that in August, so this summer, we plan to make those winner announcements. And in case you forgot, this concept phase has up to a $200K cash prize pool, which means that we are looking to award up to $10,000 for up to 20 teams. So lots of winners, lots of potential winners in this concept phase. Again, it is open now, and it closes July 26th, 2024. And with that, we can go to our final slide here. Please, if you haven't visited already, go to the HeroX website, which is just herox.com/power@sea prize, all lowercase, all one word, or you can scan that handy dandy QR code. And that concludes our presentation. So now we're happy to move to the question and answer session. Thank you. All right, so I see some questions coming through the question and answer portal. So if you have a question, there should be a little button at the bottom of your screen just called Q&A. You can just click on that and type your question in, and we will start answering these.
All right, so it looks like we have a question from Robert saying, what if we designed a new system that had a number of different components that all works together? Is it all new concept? It is all new concepts. Can we take individual components and aspects and reference them to a main unique system in several different submissions? So we would make a group of submissions that were all connected.
So in the interest of fairness and also in the interest of evaluating these proposals in a reasonable level of effort, submissions need to be standalone. They can't reference materials outside the submission, such as a website or another submission. They need to be entirely contained within the package provided. And then Mirko Presovic. Hey, Mirko. What are the parameters of subsequent phases for this competition? So at the moment, we have this initial phase outlined, and then we've released sketch details for the following phase of the competition. I think we may have, for Amanda, do we have a slide on that in our backup slides? Well, oh, go ahead.
I think we just have the slide we were just on with, one second, managing screens.
Sure.
We just have this one.
Okay. Fair enough. Yeah, so in this initial concept phase, or sorry, in this initial phase, we're looking at concept papers, and in a subsequent phase, we'll be expanding out from what we learn in this phase to try to define the rules more tightly. So this is evolving as it's going on. Carrie, I saw you come on. Did you want to add more detail?
Sorry, no, I just didn't mean to turn off my camera.
Oh,
so
okay.
I'm still here. That was a great answer.
Yeah.
Thanks, Ben.
Cheers.
And then another question from Mirko, can you elaborate what information is required for phase 1 efforts and the associated likely effort for submission?
It turns out we have a whole document that outlines what's required. Yeah, and a series of webinars. I suggest you check them out.
And then from Jason, can you speak to how the team's capabilities are evaluated and how relevant partnering with the scientific community or industry is at a concept phase?
Yeah, I'm happy to kind of speak to that one, and then Ben, I'll invite you to, or anyone else to jump in as well. I just wanted to tag onto your previous answer about what information is required and associated likely effort to say that built off of our experience, years of experience now running these prizes, we know that a lower barrier to entry with a relatively short concept phase paper that requires, compared to something like a FOA, less time and effort is really kind of the sweet spot for our prizes. And so, Mirko, to your question, I can't give you a number of hours or anything. That would vary by team, I think, but we have put this together quite thoughtfully to be respectful of folks' times and also acknowledge that $10,000 at the end it's not nothing, but it's not, going to keep a company in business for a year or anything like that. And so we have done a lot of thinking on how to ensure that the sort of submission requirements and what's needed is commensurate with the award. So hopefully that puts your mind at ease with that question a little bit. To Jason's question about how the team's capabilities are evaluated, you'll hear us say this a lot. I'll again point to the rules document, but that's only because we spent a lot of time, a lot of effort putting together really clear, transparent rules documents that outlines everything from what you need to submit to exactly how it will be evaluated. So the review criteria, we can find what page that's on, but if you open up the rules document and look at the review criteria, it will tell you kind of exactly what those criteria are. We even suggest content for you to provide for the reviewers, and then we even have the sentences that reviewers will read and then score on a scale. And so that's all described in the rules document. There's also great information on the question about partnering with scientific community or industry. Demonstrating that you've got an understanding of what that end use is important for the concept phase, but you don't need to have that completely fully fleshed out with no changes or anything like that for the concept phase. So again, more information in the rules document, but we're really just looking for folks to provide their concepts in enough detail to understand how viable or promising it is, but not so much that it's a totally onerous process for applicants, because we know that not everybody has time to set aside a month to write a proposal. So those were those two questions. Ben or anyone else, do you want to add to that?
No, I think you covered it, Carrie. Thank you. Where were we?
And we have a question from Alejandro asking if the concept is original and not patented, how will the IP be treated? And in the rules, we specifically call out which parts of your submission will be public and which will not. We definitely want you to be able to protect your IP. So we'll just have you make sure that any of your proprietary details end up in the private submission components, and you don't have to make any of that IP publicly available.
And I'll just chime in for folks that are familiar with the various government funding mechanisms, prizes have a pretty friendly IP policy. So that's all, of course, outlined in the rules document, but it's definitely worth a read, and we've tried to make it as attractive for folks to participate as possible.
Wanted to make sure that Jason, I know that Amanda provided a link, which is fantastic, but I want to make sure that Jason Higby, your question was, can you speak to how the team's capabilities are evaluated and how relevant partnering with the scientific community or industry is at concept phase? Wanted to make sure your question was answered sufficiently. Ping us again if it wasn't there. Okay, for those who aren't familiar, there were a couple of other questions that were asked offline here. Who aren't familiar, there's the HeroX platform. We're publishing materials like these webinars and the rules documents and things like that to HeroX. This recording will be up next week, but there are a number of other recordings that you can go reference, as well as other materials that should help your application. So please, if you haven't headed over to HeroX for this Power at Sea prize, please do that. And we can put a link. Well, links are already in the answer chat, but we can put a general link. Any other questions from folks? Give it a couple minutes in case anybody's typing.
And while everybody's thinking, I just want to remind you of our Power Connector, Yet To. They are hosting office hours, they're hosting one-on-ones, and we have contracted them specifically to answer questions, look at applications, make sure that you're kind of headed in the right direction. They're very familiar with this prize, and you may have already heard from some of them. Maybe that's why some of you are at this webinar. But it's a fabulous group that's really ingrained on kind of what we're doing with this prize. And so they really are a wonderful resource. We heard that there have been some folks at the office hours, but there is still plenty of room for others to join. So please do take a look at joining Yet To's office hours or one-on-ones. Again, that's our Power Connector for this prize. And there's a link for how to get signed up for those, as everything else is on the HeroX platform.
All right, we have another question. Curious what each of you and or your offices find most exciting about this particular challenge.
Oh, I can start and then invite others to jump in, but you're opening a can of worms with this, Jason, because I'm excited about a lot of this. For me, there's kind of I'm excited in two different ways. Programmatically, I'm really excited to get folks that have been working on marine energy for a while and folks that are new to marine energy thinking about it together. This is just my own personal opinion, but I've always thought that folks that were ever interested in space should also be interested in the ocean, because there are a lot of corollaries. We've got a harsh environment. It's expensive to deploy. Sometimes you have to put it out there and keep your fingers crossed because it's hard to get it back. And so thinking about having folks from other disciplines come in and work on this prize is something that I think is super interesting and something I'm really hoping to see come through this prize. From a more technical standpoint, I'm really excited about what opportunities marine energy can unlock out in the ocean. And so I'm a marine biologist by training. And so for me, it's ocean data. I think that is such a huge opportunity to have a persistent source of renewable energy out at sea that we can collect better data at higher resolution, maybe even live, kind of understand what's happening in the ocean is something that I think is incredibly interesting. So I'll stop there because I'm excited about a lot more, but invite other folks to jump in.
I'll say that I'm excited about the wide range of different technologies and energy sources that we might see come in with this prize. maybe you all were aware of the Ocean Observing Prize that we hosted before this, but that focused solely on wave energy. And I'm excited to see this prize open up the door to other types like salinity and OTEC and tidal.
Yeah, happy to jump in there too. I was just a panelist and got to attend the World Ocean Summit in Lisbon, Portugal. And one of the things that showed up there was how limited we are in our understanding of the ocean. And as we're interacting more and more near the coast and even further offshore, power is obviously one of these enormous enabling technologies. So whether we're talking about monitoring plastic pollution or aquaculture or just simple ocean observations to true satellite measurements or to help navigation or for whatever other application, there's just this dearth of capability currently in the ocean. And there's a lot of technology development that's currently happening to try to change that. And I think this prize sits right at that intersection where we can help enable some of the really neat next gen technologies that are going to make more responsible, better use of our ocean resource.
And then we have a question, will phase 2 require a successful phase 1 submission?
We're currently digging up the language and I'll link for you. Any other questions? All right, I think we have some language we're going to cut and paste in for the answer to anonymous attendee here on whether phase 2 will require a successful phase 1 submission. It looks as though we may require it for phase 2, but I think some of that is going to depend on the results that we get for phase 1. As of right now, the rules, the complete set of rules for phase 2 have not been provided to competitors. So we do have language in the phase 1 rules. We're going to copy and paste that in, and we will keep you posted.
Give it another minute or two. If anyone else has any more questions that we can answer for you today.
Oh, I see another question came through the chat, so you can drop that in the Q&A if you don't mind, Richard. But the question is, do you know how many contestants so far? The answer is we don't know. We won't know till it closes. To get a sense of who is interested in the prize, you can check out the HeroX site. There is a tab that is called Teams. And so I just clicked on it now. So we have 44 teams, which represents 882 innovators. But that doesn't necessarily mean that all those folks are going to participate. And it doesn't mean that all the folks that are going to participate are on the HeroX platform yet. So you're welcome to check that out and click through and read about the different teams. It also kind of serves as a teaming platform. So if you're interested in finding other people to work with, that would be the place to start. And while I'm talking about the HeroX and where to find things, I do just want to note that we've been referencing the rules document a lot. That is under the resources tab on HeroX. So you go to herox.com/Power@Sea prize, and then scroll down a little bit and you'll see resources, official rules is the first link. You can click there. And also resources, there is power connector support yet to office hours. So I know I mentioned that earlier. That's where you can find that under that same resources tab, as well as some of our previous webinar recordings. So the resource tab is really the place to be on HeroX. You've got your rules, you've got previous recordings of webinars, as well as how to sign up for the yet to office hours.
All right, well, if there are no more questions, then we can go ahead and wrap this up. As a reminder, the slides will be posted, so you can find any information in them on the HeroX website in about a week or so. We look forward to seeing all of your submissions.
Yes, thank you, everybody. And as always, if you have other questions, never fear, you can always reach out to us through the HeroX platform by posting a question in the forum. There's also a website, or excuse me, an email address that is in the rules document that you can reach out that way as well. Any question that we answer that would be relevant to multiple teams, we do put in the forum. So if you think you might have questions, but you don't even know what they are, check out the forum on HeroX. I also wanted to mention that we have another webinar coming up similar to this one, but of course with different information, which will also be recorded and posted on HeroX just as this one will. And that is going to be on June 26th at 12 p.m. Mountain Time. So that's 2 p.m. Eastern Time. And the theme of that one will be Innovate. So please join us for that webinar, and any other questions that you have, reach out anytime. Thanks, everybody.
Thanks, everybody. Happy Earth Day.
Happy Earth Day.
Happy Earth Day.